Hey guys, welcome back. In this video, we are going to talk about repeated multiplication and we are going to talk about transposing a matrix, okay? So, and then we are basically done with section 2.2. Once again, section 2.2 is about the properties of matrix operations. So, we know that a to the first power is a. A to the second power can be found by doing a times a. So literally multiplying the two matrices together. A to the third says take these two and then multiply it to the third. A to the k, well, as many as you have, all you have to do is multiply. And we say a to the 0 is the identity, okay? By doing this, you can show a to a certain number j, so a squared, a to the third, times a to the k, right, is going to be a to the j plus k. So think about it. A squared times a to the third. This means a. This means a. We have 5 as our k. So the exponential rules apply here. Similarly, a to the j to the k is a to the j times k. We have to make sure that these are non-negative numbers. The final part of this is the transpose of a matrix is formed by writing the rows as its column. Therefore, if A is a m by n matrix, then the transpose, which is denoted by this T, is a n by m. You're taking every row and putting into the column. So the first row would be the first column. Okay, so the first row would be the first column, the second row would be the second column, and so on. So let me take a look here. You should really discover some of the rules about transpose. So I said here we're going to discover A times B transposed, A transposed B transposed, and B transposed A transposed. So I'm going to give you A first. So what I'm going to do here is literally I'm going to take row 1 and write it for column 1. I'm going to take row 2, I'm going to write it for column 2. And this is what we call A transpose. I'm going to take row 1, column 1, and row 2, column 2. These are actually very, very important. So in order to do this, I'm going to do my parentheses first. So A times B. When I do that, I'm not going to do all the work. A times B gives me 5, 3, 13, 11. If you want to transpose it, we're going to take the first row, write it as the first column, the second row as the second column. Okay? Then I'm going to actually take AT and multiply it by BT. So I'm going to get rid of some of this stuff by, okay. So I'm going to take this guy here and I'm going to multiply it by this guy here straight up. So 1 times 3 plus 3 times 5, that gives me 18. 1 times 1, 3 times -1, that gives me -2. And that's what I get here. When you go to do B transpose A transpose, you get row 3 times 1, 3, 1 times 2, 2, you get 5. And when you do it, you're going to get exactly the same thing as AB transposed. So, let me go back here and do a page above. I believe I wrote it somewhere here, and sometimes okay. So I'll go back to those two. Here's what you need to understand. If you take something that's transposed and you transpose it again, you get back to the original. That should make sense. It should say, if I take all my rows and make them into columns, and then take all my rows and make them into columns again, I get back to the same place. You can actually do A plus B transposed as A transposed plus B transposed. And obviously the same will happen with the minus. You should discover all this by trying problems. When you have a scalar, k, it's not affected by the transpose. It's almost like you could factor out the scalar. So just A transposed. This is the key. Think about this for a second. I just showed it to you and why it works. AB transpose is equal to B transposed A transposed, not A transposed B transposed. This is one of my favorites that they did not put here. A times A transposed actually gives you back A transposed. I want you to think about this as this is A and this is B. If you transpose this, AB transpose gives you B transpose A transpose. We made A transposed into B. So this is really B transposed. That gives you A transpose transposed, which gives you back your A. So basically A transpose transpose just gives you back A transposed. Okay? So I put a few more examples here. I put, if you want to transpose the A to A transpose, you take the first row, make it the first column. You take the second row, you make it the second column, and so on. 2 by 1 becomes 1 by 2. Okay, here. Take the first row, 1, 2, 3, first column. Great. This one is important. Take this, 1, 2, 0. Take this, 2, 1, 0. Take this. This is C transposed. C transposed and C are identical. 1, 2, 0, 2, 1, 0, 0, 0, 1, and so on over here. This is called symmetric. Okay? This is called a symmetric matrix. A matrix is symmetric when the matrix and its transpose are exactly the same. From this definition, it should be clear that a symmetric matrix must be a square. Obviously, like, it can't, if it has to be identical, it has to be a square matrix, meaning it has the same number of rows and the same number of columns. If the element Aij is symmetric matrix, then every element in Ij matches Ji, okay? Except for the diagonals. That should make sense. So I is row, J is column. When you swap them, they have to be equal except for the diagonal, okay? So 1, 1, 1. These are fine, but those guys are all equal. Okay, so that's how you do that. In this case, I put all ones here. That's the only reason why it was all equal, but these don't have to be equal in order for it to be symmetric, but what needs to be, these guys have to be equal. Okay, so I think that's it for this, and I did do the example for this, I guess. 1, 2, 3, 4. The transpose is taking the row into the column, the row into the column. When you multiply it, you get 10, 14, 14, 20. Oh, I remember what I was doing now. Now I transpose this. So I took this and I transposed it. And we got, take the row, that's the column. Take the row, that's the column. I was trying to show you through example that the transpose of this is exactly the same. So I hope you had fun with these properties. You should remember them, memorize them, understand them, and they're going to help you with a lot of the future sections. Have a great day.